All right, continuing along with our examples here. We're on to example number 5. And I'm looking at, again, the first question that goes into my head, is there a problem? So I look at the denominator, and we only have a problem if we have a denominator or some form of radical, square root, fourth root, and so on and so forth. And here we do have a problem, sorry, because in the denominator, 1 minus 1 is going to give us 0. So we need to factor, since that's the only tool I've given you in your box so far. So on top, x squared minus 2x plus 1. When you go to factor that, you get x minus 1 and x minus 1 in the denominator. I'm going to common factor out an x. So I'm left with x squared minus 1. And at this point, nothing cancels. But you need to realize that that x squared minus 1 can still be factored. So the numerator, x minus 1 over x, and that x squared minus 1 is a difference of squares. And now the x minus 1's cancel. So that tells me that at 1, there is a hole if we were to graph it. If we were to plug in the value of 1, we would end up with 1 minus 1 over 1 times 1 plus 1. So the answer here is a value of 0. Okay? So it passes through the x. It would be an x-intercept, or the hole would be on the x-axis. So yes, there is a hole there, but it appears that it's going to occur at the x-axis, so our value is 0. All right, moving over here, we've got a little bit of a typing issue here, but that's all right. We'll move that over. So with that, we now have a bit of some rational expressions in here. There we go. I'll slide that over. So we're looking at the limit as x approaches 2. So do I have a problem? And the answer is yes, I do. So I'm going to have to factor. Now, when I go to factor, I look at the denominator, and it's already in factored form. But the numerator, it's not factorable at this point. 1 over x minus a half. What it has is multiple fractions. So your second part is, if you can't factor it, then you have to make, if you have multiple fractions, you must make it into 1. Okay. Now, is this sounding familiar? You're starting to think this is just doing grade 11, the 3U course all over again. I'm just playing with factoring and simplifying expressions. So yeah, you're doing your 3U course all over again. But there's a purpose for that 3U course. So when I look at my fractions here, I have 1 over x and 1 over 2. So the common denominator is going to be 2x. That means that the 1 will be multiplied by a 2 minus the 1 will be multiplied by an x. So now we have stacked fractions. Remember that we never divide fractions. So we leave the top fraction, 2 minus x over 2x, and we flip the second fraction. So x minus 2 over 1 becomes 1 over x minus 2. We see that the 2 minus x and x minus 2 are very, very close to being the same, and in fact they are. We just have to factor out a negative. So negative x minus 2 over 2x, 1 over x minus 2. Now those two values will cancel out, and I'm left with the limit as x approaches 2 for negative 1 over 2x, and then the second fraction is just a 1. If I plug the 2 in, I find I end up with negative 1/4. All right, so there we are. And now my final examples here. So for number 7, do I have a problem? 0 plus 0 is 0. So yes, I have a problem. Can I factor? Actually, if you're really, really strong with the factoring, yes, you can. Some of you might not see that immediately, and if you don't see that, that's fine. So if you see the factoring, go ahead and factor. But if you can't, What do we have? We have a radical in our denominator. If we have a radical in the denominator, your final tool, okay, if dealing with radicals, multiply by conjugate. Conjugate. All right. So there's your third tool. So you have 3 tools in total. First one's always factor. Can you factor? If the answer is yes, go ahead and factor. If you can't factor and you have fractions, you got to make all the fractions into one single fraction in the numerator, one in the denominator. And finally, if you have radicals, you may have to multiply by conjugate. So the conjugate in this case would be root x minus x over root x minus x. So the conjugate is the same as where the problem is. So our problem is in the denominator. So I need to have the exact same expression, except the sign is switched. Remember, it creates a difference of squares. So on top, I'm going to have root x bracket root x minus x. And on the bottom, it's going to be the first 2 terms squared. So that's going to give me an x. Middle terms would disappear. And the last 2 terms multiplied together, so minus x squared. At this point, I still have a problem. In the denominator, I have 0 minus 0. So now, can I factor? The answer is maybe. And so let's take a look here. I'm going to distribute that root x in on the top. So the limit, as x approaches 0, root x times root x. So as I distribute this in, root x times root x is x minus x root x over x minus x squared. Now I'm going to try to do some factoring. So the limit as x approaches 0, I can pull an x out of the top, leaving me with 1 minus root x. On the bottom, I can factor out an x, leaving me with 1 minus x. The x's will cancel. Do I have a problem? So I look at my denominator now. The answer is no. So 1 minus x, I can do 1 minus 0. So on top, I'll have 1 minus 0. On the bottom, I'll have 1 minus 0. Final answer then is 1. Okay, so that's multiplying by conjugate, and often you will have to factor afterwards. So multiplying by conjugate helps get rid of the problem. Factoring finishes it off. What about this one? Last example. The limit as x approaches 0. Do I have a problem on the bottom? If I put 0 in, I get 0 for the whole denominator. I have a radical, so that means I need to multiply by the conjugate. So the conjugate in this case will be 1 plus the square root of 1 plus x squared. So yes, if you have expressions, you can still use conjugate. So using my distributive law, the limit x approaches 0. On top, I'll have x multiplying 1 plus the square root of 1 plus x squared. On the bottom, creates a difference of squares. First term squared is a 1 minus square root times the square root would cancel out. It's an inverse operation. Going to put it in brackets, so it'd be 1 plus x squared. So going ahead and simplifying it, on top, I don't think I want to. I'll leave it for now. I'm not sure whether I want to actually distribute that or not. On the bottom, what do we end up with? So using a distributive law, remember, 1 take away 1 is 0, so we'd end up with negative x squared. So an x will cancel. Oops, just the exponent there. So it's equal to the limit as x approaches 0 for 1 plus square root of 1 plus x squared over negative x. All right, now at this point in time, I ask myself, I did the conjugate, so do I still have a problem? And I still have a problem. Still have a problem. When I look at where I am now, and I look where I started, what do you notice? What do you notice about the two? When you look at them, they look almost identical, and in fact, if I take it one step further and and I move that negative up, which I'm not going to bother, it's going to be virtually the exact same question. So now I still have a problem. I can't factor the numerator, okay? It's not possible. If I multiply by the conjugate in the numerator, okay, which you can do, if I multiply by that conjugate, 1 minus the 1 plus x squared, square rooted, I'm just going to end up back here because I'm just going to be undoing what I just did. So in this case, if it becomes a circular argument, then you have to conclude, therefore, there is no limit to x approaching 0 for f of x. All right, so if you get into a loop, if it feels like you're just going from A to B, or back to A, and so on and so forth, yeah, it gets frustrating in terms of that. And the answer is there's just no solution. There's no limit possible. All right. The homework is on the next page here. Eventually, too, and I'm not sure whether it's this lesson or later on, there's going to be a PDF to also print off with extra limit questions. And I think maybe there's 2 actually. And the common complaint or commentary from people returning from university, when I asked them what could I strengthen in terms of the program, the comment is more work on limits, being more comfortable with limits. Limits is something that takes time and experience. So I'm going to spend another day or so in total on limits, but there'll be a couple more questions for you to work on. It's just working on that comfort level.